Hello. So today we are going to try to draw the most perfect shape in the world, the circle. And actually, we're going to draw four circles, a big circle, and inside the big circle are three smaller circles. And these three smaller circles, they share a point with each other, and they also share a point on the circumference of the larger circle that they are inside of. And we are going to use Geogebra, which is an online geometry tool, to draw these circles. We are going to mess up. We're going to think that we have it, and when we put the last piece in, we're going to miss it. We're going to get something that isn't perfect. But we shall use some insights and principles from geometry and algebra, and we will be able to recreate the drawing that you see in front of you right now. So this will be really cool, and let's get started. Here we are in Geogebra, which is the online tool that we're going to use to construct the diagram that we were looking at earlier, which is a large circle with three smaller circles inside of it. And we're going to start by making the smaller circles first. So we're going to make the radii of a small circle, and based on that, we will make the other circles. So here we're going to select segment with given length, click a point in space, and there's our first point, point A, and we're prompted for the length. Now this is where it might occur to us that we don't have any measurements for anything in the diagram. We don't know how big any of the circles are. So we'll have to make some working assumptions. Let's assume all the small circles are the same length. They kind of look like they are the same. And let's assume that their length is, the radii length is 1. So they are all unit circles. And this is really practical to do, because if we have to crunch any numbers, if we have to do some arithmetic later, it'll probably be easier when the lengths are 1. It makes the math easier. So let's say that the length is 1, and this will be the radii of the first circle. Now we're going to go to circle with center, and we're going to click A. Drag our mouse to the left, rather drag it to the right, and there we go. We have our first circle. So now let's do the same thing for the second circle. So we're going to go segment with given length, press B, another unit circle, and there's our line segment that will form the radii of the second circle. We'll go to circle with center, and we're going to this time click C and drag to the left. And boom, we now have 2 unit circles. Now we have to make the third unit circle, and this is where it gets a little tricky, because the third unit circle is some distance away from point B. There's some space over here, and we don't know exactly the distance from point B to the central point of the third small circle. But we can use some principles from geometry and some math to figure this out. We're going to use special triangles, and we will be able to input the exact point for the central point of the third circle. So we're going to do that next. So this is where we left off last time. We have made the 2 unit circles, and we are now trying to make the third unit circle, and this is where things get a little tricky, but still totally doable. So the challenge is that we have a third circle here, but there's some space between the third circle and the other 2 circles. There's some space here. We're not exactly sure how much space there is, and we have to try to find the central point of the third circle, so that when we make this circle, Everything is the way we see it in the diagram. There's some space here. They're sharing a point here and a point here. So the way we do this is first we have to use our imagination a little bit. So let's grab a point here. Boom. Okay, so this is tentatively like a central point for the third circle. Now, we know that it's got to be directly under B. This looks like it's a little bit shifted to the left here, but we'll fix that. But the idea is that it has to be directly under B, and it has to be kind of like diagonally from A. And if you think about it, this is also unit circle. So the radius from D to like a point, here would be 1. And the distance from A to this point here that they're going to be sharing is going to be 1. So this distance should be 2. It should be 2. Now, over here, we have a distance, and it's actually, it forms a triangle. So over here, A to B, we know this is 1. So if this is 1, and this should be 2, then we have a special right triangle, and we can use Pythagorean theorem to figure it out. And because we're using unit circles, the math is pretty easy. So if AB is 1 and AD is 2, then BD is the square root of 3. So that means that we have to drop a distance of square root of 3 from B's y value, and then we'll get D's y value. So let's do that. We'll go to the calculator, and B's y value is the same thing as A's y value, because they're the same point on the horizontal line that is with a slope of 0. It's flat. So A is 1.4163, so that's also B's y value. And so now let's go to our calculator, and we're going to put in that value, and we're going to drop it by a value of square root of 3. So minus, open parentheses, 3 square root, close parentheses, equals. So the y value of point D, for it to be directly under B, such that it will be able to make a right triangle with A, is negative 0.3157. So so let's enter that into D. So let's go to point D, and you see over here it has this other number, 0.03327. We actually don't need that number. What we need is this number, negative 0.31575. That should be close enough. Let's press enter. Oh, you see, so D moved a little bit lower. So this space, right, is going to be a little bit bigger than like I initially thought it would be. Now we have to just make sure that AD is all on the same line, and would be a distance of 2. So to do this, we have to solve an equation, and it's an equation that uses Euclidean distance, which is just like the Pythagorean theorem all over again. And so let me use some software here, Mathematica. So Mathematica will now solve for the value of x for point D, given a line from A to D. This is point A over here. This is point A, and this is point D. And this line, its distance, it should be 2. And so now we have to know what x should be. So let's run it. And so it gives us 2 possibilities for x. And because, D could be, you could have like, you could have this line be below A, you could have it be above A, it'll still be 2. So let's take this one, negative 1.3059, copy it, and let's put that into point D. You see, it's very close, negative 1.28. So we were almost to the right place, but we want to make this perfect, right? So now we press enter. Oh, let's go back. Comma, parentheses. That should do it. Okay, there we go. And there's D, and now this would make a perfect right triangle, ABD. And so now that we have the central point for D, we can now use this to make the third unit circle. So let's go back to our GeoGebra tools and click circle with center. Click D. Oh, actually, we needed a circle with radius, so let's just undo that. And circle with center radius, click D, and our radius is 1. Press OK, and boom, there it is, perfect. We got our 3 unit circles, it's perfect. Now we just have one last thing to do, which is create the larger circle. And then we're done. So let's do that now. So here we are almost done. We have made the 3 smaller unit circles, and now we have to make the larger circle that will encompass these 3 smaller circles, where the larger circle will share a point with the smaller circles. And in order to do this, we have to calculate the radius of the larger circle. So we assume that the radius of the smaller circles was 1, and the radius of the larger circle will clearly be greater than 1, but we need to know exactly what it is. So we know that the central point exists somewhere over here, most likely. That seems to make visual sense. And but we have to know where that point is exactly, so we can get the distance of the radius correct. So this point that exists somewhere over here, which is the central point of the larger circle, is very special because it is also the center of mass in a triangle that is formed by these 3 points. If you can use your imagination, you have A, C, D, and this triangle forms here, and the center of mass of the triangle is also the central point of the larger circle. So how do we find this point exactly? We can find the center of mass of a triangle by this procedure, which I'm going to show you now. So first we have to get the midpoint of A and D. So there's a tool to do that. Let's see. If we go to midpoint or center, here we go. 1, 2, and there's the midpoint, E. And let's do the same thing for C and D. And now we have to make a line that goes from E to the opposite angle, the angle that is opposite that point, the vertex over here at C. So let's do that. Do a segment, line segment, E, C. And now let's do the same thing, F, A. And you see how they intersect here? This is it. This point is the center of mass for this equilateral triangle, and it's also the central point for the larger circle we're trying to make. By the way, if we did the same thing, B to D, you can see it crosses the same point. It's the center of mass. You could balance this equilateral triangle on that point. So so now we have to calculate the distance. So let's calculate the distance. We have something here in GeoGebra that we're going to use. Let's see if it works out for us, which is measuring the distance. So here we have measure, and we should put down the point first. So this point, this intersection, that's point G. So let's measure the distance from G to D, because the idea is that if we add up the distance from G to D and from D to the circumference of the circle, so that's another radii of the circle, and we know that's 1. So if we add GD plus 1, we should get the radius of the circle, of the larger circle. So let's let's measure the GD. GD, it's 1.2, and we know from D to like the circumference is 1. So that means that the radii of our circle should be 1.2 plus 1, which is 2.2. So let's see if that works. So we're going to do now, we're going to make a circle, and we're going to say circle with the circle and radius, and the radius we calculated to be 2.2. Let's see if that works, and it does not work. The circle is too big. So what happened here? So what happened was that this measurement is not precise. GD equals 1.2, it's rounded. And the thing about circles is that if you're just a little bit off, if you don't have enough decimal places, you're going to miss. That kind of makes, if you think about it, it sort of makes, because circles are found on the moon and on the planet, they're spheres and orbits. And so it's kind of amazing that humankind was able to, put astronauts on the moon, because if they were off just a little bit in their calculations, like we are here, we would be a little bit off, and that's it. We wouldn't make it. The spaceship would miss the target, and something like that. So we need a more precise number. So we can get a more precise number, because remember that this b to d is the square root of 3. We calculated that earlier because of Pythagorean's theorem. And one of the facts about the center of mass for an equilateral triangle is that it's found 2/3 of the way to the height of the triangle. So this is actually 2/3 of the square root of 3. That is actually the more precise distance of GD. So let's get a calculator, and let's calculate the precise distance of GD. So it would be 2 divided by 3 times, open parentheses, 3 square root, close parentheses, equals 1.5470. So what happened was that it rounded off to the 10th place, and so that makes it 1.2, and that was too big. So we're gonna use this better number here. So 1.15470 plus 1. So let's add 1. And so our number is 2.1547. So now let's make a radii. Let's make a circle with that radii. So we go to circle with center radius, and it's 2.1547, and press OK, and boom, there it is. We did it. So this is a great experience, and it just shows you how beautiful geometry can be, and how it's important to be precise, especially when you're making a circle. Thanks for watching.